Welcome everybody. My name is Alberto de Santos and I will be here to start this project called Chopyn, which is focused on creating music based on artificial intelligence. This is going to be a travel which will consist on learning both Python and artificial intelligence, and the focus is just very simple, which is let's create some art, let's create some music, and let's see how it sounds and how we can do this. Why I have selected the art of music, because this is something that only humans can do. Some animals can make some noise, and some animals can make also some kind of songs by whistling or making some sounds, but creating music is something that is only reserved for humans. So the best way to create music artificially is based on some rules, and also using some artificial intelligence to infer that rules and to create some music that is very similar to the actual and to the current music. So let's start with the name, which is Chopyn, and what exactly is this project? What exactly is this all about? All this, live streaming, all this thing. Well, actually, this is just an experiment, and this experiment consists of both things, which is the main focus is to create an artificial intelligence system, but also the idea is to know how to create a project, a research project, and a project based on artificial intelligence. So we will start from the very beginning, from scratch. We will start from a completely blank page of code, and we will be creating all these things. In the end, we will be able to listen to some music, and the idea is that the code and all the project repository will be shared through GitHub. There you can see the URL, but you can see this URL anyway on YouTube. Okay, so every Wednesday, what I will do is that during the week I will be making some progress by myself, and during completely on Wednesday at 8:30 Central European Time, I will be making some live streaming programming, which will consist of some tasks that I will keep this task only for that Wednesday, so that I can share with you the way we can make this program, okay, all together. The idea is that the first release will be on Christmas, this Christmas, almost in 3 months, and in 3 months we will be able to create music artificially, but not in any way, but with some sense, and just taking into account all the different data sources that are out there, and also all kind of music that is out there. So we are going to learn from that. This is something that is not new, but the way we are going to implement this is something that I hope is really new for you and also interested. So why Chopyn? Because Chopyn is the combination of a very famous composer, which is Chopin, which is up there on a I think it's the most famous picture of Chopin, and also the combination with Python, because everything is going to be written in Python. I really like this language, and I think this is one of the best languages to write artificial intelligence. So this is the happy name, and Chopyn will be the project, and for sure you can find all the code and all the project on GitHub. But what maybe you are asking yourself, which kind of music are we going to reproduce or to imitate somehow? Well, there are many different kinds of music actually. If we go back, but when I say back, I can say maybe 2,000 years, we can find, for example, the music from the Greek people. This is really the beginning of the music. But what we call music starts, after the Middle Ages, and start with the Baroque, and also which is followed by classical, then romantic, and then modern. I think these four types of music are the most common one. You also have, the Gregorian monks, which are also very famous. You have music from Renaissantism and all those periods that are also very important. But the most important thing is that these four groups are, the most important groups actually. So we will be focusing on these four groups. But concerning music, it's not going to be only, probably like, Debussy or all those composers, but also we are going to use music from Elvis or from, Beatles, and also from, U2 and all those current composers. Okay, so we are going to learn from everybody. We are going to learn which is, the most common pattern, how we can make music, and how random ideas or random melodies can be converted into music. That is the main idea of this project. But first of all, let's listen to some music, because although there are different periods of music like Baroque, classical, romantic, modern, or very modern, rap, jazz, rock, and all those, all of them are the same, and I will show you. So what I'm going to do now is I'm going to share with you some music that I hope you like. First of all, I will start with what I meant by Baroque, because probably you don't know exactly what is Baroque. Baroque is one period that goes from the 16th century to almost 18th century. I hope you can see now the screen. Yes. Yes. So this kind of music sounds like very old music, and I will let you listen a bit. So as you see, this music is, quite easy to be recognized. It's, let's say, quite old music. It sounds on a very specific way, like if you are in a church, like if you are on a small chamber, okay, like if you are on a very, very, very old time, okay. But this music is, they have the same rules as this music that I'm going to play right now. Imagine you now listen to this. One moment, I'm going to feed the screen. So you can see the visualization. So this music is what we call in classical music. This is called modern music. The modern music comes from, the 19th, 20th century, and specifically this is Moonlight from Debussy. Okay, it's a very, very nice music. Also, on this course, we will be able to make this kind of visualization. So I will show you how to create this visualization and to align them with the music. Okay, so this is Debussy. Debussy is one of the I think nicest composer ever. It's very difficult to play, but it's very nice to listen. But music is not only classical music. We can have also soundtracks, for example, music that comes from several films, which has also the same structure. They have all the time the same rules, the same harmony, the same notes. They are pretty much all the same, which is you have 12 sounds, 12 different sounds. They are only 12 sounds, and the way you combine that gives you different type of music, but the rules are pretty much the same. Okay, I'm going to maybe download this a bit. Okay, and yeah, this is a very nice piece of work. So this is more probably you have listened to this a bit more than the others, but in any case it's also beautiful music. And finally, let me share with you a nice video on what can do if you are creative with music. We're going to listen to Maurice Ravel, Bolero, and the Bolero from Maurice Ravel is it's very, very famous. You will recognize it very, very easily. And you can see how if you have a bit of imagination, you can do very, very nice things on music. In this case, we will see 3 players playing on a cello. Okay. Of course, if you listen to the music, you will recognize this piece of work. Now, in a moment, something will happen that I hope you will like, which is another musician. Of course, there is almost no space. But if you think on the music, or like let's say like a string, and you divide the string into different parts, that makes the different sounds. Okay, that is the frequency. The frequency is called pitch in the theory of music. So what they are doing is just sharing the same strings, and they are playing on different strings, and that is the reason why they can play them together. Okay, so I hope you like it. Now it's time to come back to the presentation. I hope you like the music. So now it is important to see which kind of tools we are going to use. So concerning tools, I will use I would say the most simple tools, those tools that are available for all of you, and so that you can take the code, you can make your own code, or you can commit your code, branch everything, and and collaborate with this project. So concerning the repository, I will use GitHub. I will use Python as the main language, and concerning Python, I will use some deep learning framework, which is Keras and TensorFlow. We will see how we can create, how we can index 3, which is one of the best, in my opinion, to edit your code and to create your own stuff. And in order to make visualization, we will be using the next logo, which is not the box, which is the blue one, and also the orange, which is Blender. So we will be using those 2 for visualization, which is something probably pretty new. All of them are based in Python. They can have different scripts in Python, and it's quite straightforward to use. But yeah, we will dedicate one session only to how to use Blender or how to use Notebox and how to display and how to visualize music. So I hope you don't, but in case you are thinking that maybe I'm crazy or why I'm dedicating my time to this thing, it's because I really believe that the artificial intelligence must be used not to learn from the past or not to, create only some nice machine learning models, which is some part of the artificial intelligence, but also to imitate how the humans create art or how the humans think or how the humans create new things. And creativity is associated to art, and one of the most common arts is music. That is the reason why I'm focused on this. But I'm not the only one. So if you have a look to the literature, if you have a look out there to the state of the art and you make some Google queries, you will see that there are already some products that are able to, to create music. One of them is DeepBug, which comes from Spotify. DeepBug creates music very, very surprisingly very similar to Bach. And why Bach? Johann Sebastian Bach belongs to the Baroque period. Johann Sebastian Bach was one of the most prolific, one of the most talented musicians ever from the Baroque period. You have to think that he lived, if I remember well, in the, I think it is 1600 something and 1700 something. I don't remember now precisely, but he was able to create many different pieces of music, and he was, he stated all maybe the main rules of the modern music. Actually, Bach is so important that the jazz music, the jazz from Louis Armstrong, the jazz from Liza Minnelli, they are based on the way Bach make all the compositions. Okay, so what Spotify did here is just to learn from all the different pieces of work of Bach and to extract the main intervals, the main tonalities, the main musicality, the main melodies of Bach, and to infer that behavior and to make prediction on which will be the most common sound after a given sound. Okay, that is deep Bach. But you can extend this. You can extend this a bit more, and you can use, for example, Magenta, which is based on TensorFlow. The code is already also on GitHub, and you can play with it. And Magenta is something very nice because you can create different types of music. It doesn't have to be Bach specifically. It can be any type of music. Actually, if you go to the Magenta site, you can see how if you play random notes on a piano, you will see how Magenta software is able to continue that melody and to create some polyphony. And polyphony means that you can play different voices, different melodies at the same time. And this is something really, really beautiful. I really recommend to see that demo actually. So I'm happy I'm not the only one. Some research is being done actually, and although probably it makes no money, probably there is no money behind this, or if it's very difficult maybe to justify that you can research on this. It is obvious that we can learn a lot from how the humans create things, how the humans create music concretely, and how can we imitate that way, that creativity. But yes, this project seems probably something that is unachievable, right? So if you have a look to the state of the art, to the literature, you have Spotify and TensorFlow that are not precisely something new in terms of, in the field of artificial intelligence. So it seems that this project probably is quite ambitious. Yeah, it is ambitious, and this is why I would like to start this project and I would like to share this with you. So if you want to, start a big project as this one, the first thing you have to do is to think on your first step. So imagine you have no idea of music. This is something that is not required here, so you can come here to this project without any idea of music. Okay, music is not required. You can have probably very little skills, very few skills on programming. That is also something that it is not required in this course, or in this project. But afterwards, you will learn how to program a bit and also some knowledge about music. Okay, so this is something that you can take with you after this project. So this is what Chopyn is all about, starting from the beginning. So let's see which is the first steps you have to do in order to create music artificially. So today we're going to create only 3 steps. Okay, the first step is to create all the different notes, all the different sounds, which are 7 if we think on the standard scale. Okay, on the standard sound scales, which are those that you can see here. If you are a Latin speaker, you pronounce the 7th note as C. If you are Anglo-Saxon speaker, you will pronounce it as T. So it will be like fa, sol, la, ti, do, which is something that I'm not going to do because I prefer to say C. Okay, so the first step is let's model these notes. Let's model this note in Python, and let's create do, re, mi, fa, sol, and all those notes. And afterwards, let's create some random melody. For now, we will create only one random melody. We don't need now to think a bit deeper on how to create music. Okay, we only need a sequence of random music for now, and later we will create some script in order to convert those Python programs, those Python classes, into something that you can hear, something that you can listen to. That is the most important thing. Okay. So now, what I'm going to do, okay, is to stop talking and to start programming. Okay, so the idea now is that I'm going to explain how to create all these 3 things, and what I'm going to use is just the Sublime text editor that I'm going to, share with you right now. Okay, so this is it. You can see it now. Okay, great. So yes, now you can see, and now I can write. So first of all, we will have here 3 kind of only 3 codes. Okay, which is the play.py, which is one class that is already written and it's already available. It's something boring, which this convert the CSV into MIDI file, and this is something I'm not going to explain right now, but this is something that is already commented and that is available for you. So the idea is to work on this class, okay, which is completely empty. Okay, so the idea is that, okay, I hope you can going to increase the size so that you can see it better. So the idea now of creating what we have seen before, which is we have to create musical notes, okay, which is do, re, mi, and so on. So the best way to do this, in my opinion, is to use classes. Okay, so instead of creating one specific class for every node, that I will do this later, I will create one, let's say, mother class, which is let's call it, okay. So this this class, which contain the musical note, must have four properties, which is the duration of a note, which can be, for example, we can have long or short notes. Okay, that is one property. The other property is the pitch or frequency. It is called pitch for short, and this is if you have very high pitch. There is not a synonym, but high pitch frequency is that if you speak like this, and a low pitch is like if you speak like this. This is the difference between different types of pitch. Okay, and this can be high or low pitch. Another property is intensity. The intensity means that you can speak, the sound can be louder, or it can be soft. Okay, so that is intensity. And the other property is called timbre. Which is timbre? Is the instrument you use to play. So why? Because imagine we have a sound which is one La, and it is called louder, which is F from forte. Okay, from that is mean loud, and you have a duration of, let's say, 3 pulses, and you play this with a violin. If you do this and you use, for example, a piano, they have the same duration, pitch, and intensity, but they have different timbre. Okay, it is not the same note play on a violin than the same note play on a piano. So this is now, very simple, because we have now to define, the main like the constructor, and this constructor, in my opinion, must have we can have two different approaches. One approach is we can use, for example, something like put all the parameters here, like pitch, duration, and so on, which is something quite verbose. Okay, or we can use, something like this, which is something, in my opinion, much nicer, and that can save a lot of time. Okay, so with this, imagine that, for example, now in order to do this, the only thing I have to do is just, for example, this way, just notice probes, and now it is very easy, because now we have the duration. It is called directly like this. Okay, so now the only thing I have to extend is just the other properties, which are only one more. Okay, and this is called pitch. This is called pitch. Here is intensity, and finally timbre. Okay. Okay, why I'm doing this? Because my idea is that I can use, for instance, can create any node, something like this, using some parameters on a JSON like structure. Okay, so that make me very easy to create music. Okay, so in order to test this, okay, let's do something like this. So if name, let's create kind of a executable code, which is here. Okay, this is the way you just create a, let's say, an executable code, and we define some nodes props. Okay, and this can be doing this way, which is pitch probably something like 12, duration means 100, and timbre can be, let's say, 2, and finally pitch and duration and intensity means 4. So now we have the nodes props, and the idea just right now is just to use the class to create nodes props, and just to use this. So probably this will fail for sure. Yeah, really, yeah. Something is here. This is what it's all about, which is I will commit some errors, yeah, now. And the idea is to correct them, because this is what live streaming programming is. Okay, so let's think on what I have done, which is I have just defined the global musical notes, the musical note structure, which is, let's say, like the mother of all the notes, and the different notes like do, re, mi, fa, all of them will be inheriting from this class. Okay, so now the idea is that, okay, I have all that structure, and very simple is, let's create do, which is obviously a musical note. Okay, and this musical note is created, yes, like, let's put one simple comment, which is create musical note do. So the idea here is similar, like we need a constructor, but this constructor, let's avoid this. This constructor must inherit from, from the father or from the mother class, and I have to use the super structure, which means that I have to inherit from musical note. I want to use this, this constructor, because that is the idea, because do, re, mi, fa, sol will be pretty much the same, but the only thing that will change is the only thing that will change is just only the parameters. But concerning musical notes, only the pitch will be fixed. That is the only thing that is defined, but by a musical note. Okay. So I will just call init, and to use, I need to put here nodes props. Okay. So with this, yes, what I do is just something like, if I do something like this, this is a very straightforward way of testing. This is something that we will be also doing on the project. Probably I will do this during the week, so that you don't see how I create all the tests and all that boring stuff. But yeah, it works. But this is something that I will be doing for sure. I will be creating some tests which will be more concise. But in this way, the class do and the class musical note are pretty much the same. So they are very similar. Actually, they are the same. So what I have to do here is, the difference between do and a standard musical note is that the do have a specific pitch. Okay, that pitch do has a specific pitch. This is something that is fixed. Okay, this is something that doesn't depend on any other parameter, so that is completely fixed. So I will tell you later which I think is 60. For the MIDI files, there are some code, and I think that, if I remember well now, do corresponds to 60. Okay, so when you convert this into MIDI, 60 is converted into a standard do. Okay, so there are different dos, different musical notes with the name do. It depends on the scale, it depends on the different octave they have, in the different octave they are. So at the moment we will focus on one single. And actually the way we have created notes probes, which is something that is not fixed, okay, so that makes very easy that I can add some different parameters. Another parameter is that, for example, the sharp, for example, which is, the idea is that if I know that the pitch is 60, I have to update only the notes probes accordingly. So the idea is that I will use the update and I will just fix that the pitch is 60. So in that case, if I run this, everything is going to be the same. I don't have any way of seeing if pitch self, and the idea is to return here self pitch. So I will ask, tell me which is the pitch, and just return the pitch of that note. Okay, so if I do this, okay, if I do this, and now I will be storing this standard musical note, and this is a do. Okay, if I do this and I say let's print do dot, that is 12 and 60. So yeah, it works. So doing this, I can update the pitch, which is the frequency, okay, of that note. Duration and timbre and intensity, this is something that must be provided to define the do, but the do has a parameter fixed, which is the pitch. Okay, so now it is very, very straightforward now to create re. Re class also inherit from musical note. Here is re, and the distance between do and re, they have two half of tones, and this is the way every half of tone is represented with 1 on MIDI, and that is the reason why do is 60 and re is 62. Okay, so everything is the same, okay, and the only thing I have to do now is just to, okay, I'm going to create re here just to see if it works, and just to ensure that yes, it has changed. Okay, it changes for 60 to 62. Okay, for now the idea is that we have already covered the first step, which is which is about this thing, which is I have already created the notes. I don't need for now more specific things. Okay, I don't need to know now, for example, to implement if that note is on a specific tonality, if that note fits well with another note, if that has flat or sharp or something like that. So at the moment I don't need to do this, okay, because for now only with the definition of the properties of the notes and fixing the pitch for a specific note is more than enough. Okay, so this is what we need to know about the music note. So the next step is to create one melody. So one melody is a sequences of notes. So this is something that now is very easy because we have already created the class of the musical note, and what we have to do now is just to import from musical notes, import, I would say everything, but of course you can import musical note, do, and re, but I think for now I would say import everything. And the melody will be converted into CSV to MIDI file. So I have to also include this to from play file import CSV to MIDI. Let's see. Yes. Okay. And I will be using also some important libraries from Python, which is NumPy, as I will be using some. I will be using some. I will be using some methods from this library, and also some data frames. So I will be using also these two libraries. Okay, that is for sure. So the idea is, as I told you, I'm going to create a random melody and a random let's write it here, random melody. And a melody is a sequence of notes, okay, with a specific time, a specific duration, and all those things. We can make this completely random if we want, okay, but for now we are going just to define the name, which is very straightforward, okay, random melody, and we are going to use our very dirty test, okay, something like this, okay, because I think that is useful for now for this first lecture, okay. Later on I will take, as I told you, I will create some more robust way of testing all these things. So finally, concerning the random melody, I will create, as expected, the main method. So the main method, the constructor means only needs something like this. First of all, we need, let's say this way, some properties here. These properties can be created also randomly. These numbers can be, later on we will do it, can be created from random distribution, but let's create it now from very fixed data. So I will use this, and I will create just a sequence of notes. This is actually the melody, and this sequence is just an array with some notes, okay, and these they will have all of them, okay, the same duration, timbre, and intensity, okay. Remember that the pitch will be updated for everyone. Actually, I can take it out. Yeah, I will take it out. Okay, so now I would say I will create a very nice melody of three. Let's say this way and this way. So I will create this melody, which is do do re re do do, very straightforward. That will be our first melody, our first sequence. Okay, later on we will create some nice music or some famous melody. Okay, so yeah, this is it for now. Okay, because now what I'm going to do is just to initiate the sequence of notes. And now what I have to do is let's convert this into a MIDI file. Okay, so in order to convert this into MIDI file, I have to take into account this thing, which is, let me start from the beginning. This is a CSV file structure. Okay, this CSV structure is used to convert this into MIDI. The MIDI file is something that you can listen to. Okay, you cannot listen the CSV file. You have to listen the MIDI file, and the MIDI file needs the information like this, which is you have all these voices, which is 0, which is the header, 1, which is the information about the track, and now here you have the voice, which is we start the track, we indicate that this track will be played by, in this case, by a specific instrument. That instrument is given by the number 1, which is the piano. Okay, and then it says something like, at time 0, you will play, the note will be on, and that has 65 of pitch and then 36 of intensity. And then 250 milliseconds afterwards, you stop talking, you stop playing that sound, and in that moment you start, playing another sound, which is 62, and then at 375 milliseconds you stop playing 62 and you start playing 67, and then 67 is stopped after 125 milliseconds, and then it starts 64. That is music, one note after the other. Okay, that is how the melody works. So in order to do this, I'm going to reduce the size. So in order to do this, what I'm going to create is just a method. And as I told you, all the things related to convert to MIDI is something that I'm going to avoid, okay? Because I think it's something quite boring. So what I'm going to use is this thing, which is, I'm going to tell you right now, which is, first of all, what I need is to create that sequence of milliseconds. Those milliseconds are a cum sum of all the duration, okay? So that duration is what you need to extract for every note from the melody. So what I do is I will iterate on the self sequence of notes using this comprehensive list of Python, and for every note in the melody just give me the duration and make the cum sum. That is the reason why I will call this start milliseconds array. So with this I will create very simple data frame extracting all the different properties from the array, okay, that we have here in the sequence of notes. And what I will do is just to paste one column with that star ms, which is the column of the milliseconds. And finally, what I will do is just to, as I say here, to rename the columns. As the MIDI file has already specified this here, we are able to create some tests, which is something like this. So the idea now is, okay, we have one class, which is random melody. Okay, with this, okay, we create the music. We cannot see, any output. And then now it's time to call to the convert to MIDI method, which will be adapt the melody to the CSV files. Okay, so now if I run this, for sure there are some problems. It is about the main module. Okay, this is something, sorry. Okay, now we have here CSV to melody, and from melody we call to the convert to MIDI file. Okay, now as usually one error. And okay, this method they call get duration and get props is something that we have, as it says here, we have not implemented on the musical note. Okay, so this is something that we have to solve right now. So in order to do this is def get duration self return self duration, and finally extract all the properties. Get, I think is get props the name. Yes, get props self not props. Yes, right now it will work. We hope so. Yeah, it worked. If that is slow, it is because I'm sharing my screen. I'm, making this live streaming, and the computer is a bit slow. But now, the idea is that this file called, if I don't remember what it's called, music CSV, is something that we can listen to. Okay, and let me see. Yes, here data and the output. Okay, I'm going to share with you let's see if I see it. No, now I cannot see it, which is the GarageBand. Yeah, let's see if I can share it with you, the GarageBand. I think I cannot share this. Yeah, in any case, I'm going to share my screen. The source house display capture. Yeah, I think now I'm going to fit this to the screen. Okay, let's see if I don't. I think this is something dangerous. Okay. So the idea is that this file is created. Let me show you, because this is the only thing you can see, I think. So on the data you will have yes, you will have this data, which is the music CSV where, and on the data, on the output, the CSV, I think is this one. Yeah, now. So now here you can see the two do, the two re, and finally the two do. And this is something that we hope that this is our next and final step, which is something that we can listen to. Okay, but in order to listen to this, let me see if I can finally share the screen. Yeah, now, sorry, now I can see. Okay, so now, yeah, here you can see how there are, like, on the green screen, on the green thing, that is the music we have created. It's very small, of course, but we can do something like this. On the melody, on the configuration, we can see we have here, we have 100 and we can put 1000. If we run this, in 6 seconds we will have it. Okay. Yeah, and then I have to open this again. don't save, and you will see how this changed dramatically. Okay, so I hope you are seeing, yeah, you are seeing it right now on the GarageBand. Now you can see how the do, re, do notes are being displayed. Okay, so I think you cannot listen to this actually because of the source. Let me see. No, you cannot listen to it. But what I can do is definitely. I hope now. Yeah, so that's it. You have already created your own music. Okay, so this is probably the end of this lecture. Okay, I hope you didn't get very bored with this live programming. But finally, let me create something for you. Let's create some music a bit, a bit longer and a bit nicer for you, which is probably, let me, yes, not this one, probably this one and this one. Yeah, now, so the idea is that we have only, on the musical note, we have only, only 2 notes. This is something that is something that it must be changed right now if we want to create some music. So if I'm going to create only 4 more, or why not the whole scale? Okay, so we have do, re, this is very easy, this is mi, and re and mi, there is half one tone, which is 64, this is fa, and this is fa, and this is, yeah, 65, this is, yeah, 65. We have sol here, which is, yeah, 67, and finally la, which is 69, because they have, one tone, and finally C. C, this is 69, then 71. So yeah, it worked. So now let's see if we can create some more complicated music. Okay, so let's do something like this. Do. Sol, sol. Yeah, one moment, because this is like playing piano. This is like playing piano in a very weird way, So this is one melody that you will know for sure. This is mi, and finally this is do. However, in music there are, as we will see in the next self-streaming programming, in music we have different types of duration, so you cannot do everything with one single duration. So the idea is that duration must also be, multiple of one of the other. So that's the reason why I put here 2000 for the long notes prop. So if I do this, and if I run it, cross fingers, because I think that would work for sure. Yeah, perfect. So now, if I open the same MIDI file, and while I open it, I'm going to, share with you the screen, and I'm going to, feed this into screen. Yeah. So this is a very much longer melody. It's not random at this moment, okay, because I have written it, and I hope you recognized it, this melody. It doesn't sound. I don't know why. Can you open it again? So I will open again. I will check it. So now you should see. Let's see if you see. Yes, you see. Okay, you can see, and don't know why it doesn't work. It doesn't sound. So let's see now. Okay. That's it. That's it. So this is how you can create, the music. I hope you like it. I hope you find it interesting. And if you have any doubt, just let me know. I will upload all this code to the GitHub, and the next week what we'll do is just to keep modeling the music notes. We will include the flat and the sharps, and also what I will do is just to introduce the concept of melody in a more, let's say, more advanced way. Okay, we will be creating more random music, but we will include some rules, and you will see how just applying some simple rules you will be able to listen very nice music. So thank you very much for attending this, and see you soon in the next live stream. Thank you very much.